Hello, everybody. Obviously, I am not here today, so I am recording this video on Monday afternoon so that we can go through this lesson together as you're watching this video, and then we don't fall behind. So you should have been handed or given a handout with all of the problems and examples in today's lesson. So go ahead and make sure you have that ready because we're going to be filling that in as I go through this lesson. Let's go ahead and start with the warm-up, which is on the front page of the handout. So a customer at a bagel shop is buying 13 bagels. The shopkeeper says that would be $16.25. Jada, Priya, and Han, who are in the shop, all think it is a mistake. Jada says to her friend, shouldn't the total be $13.25? Priya says, I think it should be $13. Han says, no, I think it should be $11.25. Explain how the shopkeeper, Jada, Priya, and Han could all be correct, all be right. So we're going to go through these one by one. So we're first going to do the shopkeeper. Okay, so the shopkeeper said that the total is $16.25. So we're doing the shopkeeper first. And remember, he said, or she said, the total is $16.25. So what we want to do is we want to see how it would be possible to get $16.25 based on these prices here. So what I'm going to do is I'm first going to check the price of one bagel. So let me pull up Desmos on my computer here. Okay. So on this, we're told that the price of one bagel is $1.25, and they bought 13 bagels. So is $1.25 times 13 bagels is $16.25. So how could the shopkeeper be right? The shopkeeper could be right because he multiplied the price of one bagel by 13. $1.25 times 13 is $16.25. So that is how the shopkeeper could be right. Let's look at Jada's total. Jada thought that the total should be $13.25. So how could we get $13.25 based on these prices here? So hopefully we can see, right, if 6 bagels are $6, if I multiply that by 2, that would give me $12, and then add another one, because remember, we're buying 13 bagels total. So if you do 6 and 6 and 1, that gives me $13.25. So let me write that out to make it a little bit more clear. So if you buy 6 bagels plus 6 bagels plus 1 bagel, that's 13 total. So that would be $6 because 6 bagels is $6 plus $6 plus 1 bagel, which is $1.25. If I add all that up, that's $13.25, which was the total that Jada thought it should be. So we've shown how Jada could be right. Let's look at the next person, Priya. So Priya thought it should be $13. So that was her total. Okay. So on that one, we're told that 9 bagels is $8. All right. So if she buys 9 bagels plus 4 individual ones, so plus 1 bagel, plus 1 bagel, plus 1 bagel, okay, that's going to be $8 plus $1.25 plus $1.25 plus $1.25. And actually, I missed one individual one because that only gives me 12 bagels total. So if I add one more individual bagel, that would be another $1.25. That would be another $1.25. And if I add all that up, 8 plus $1.25 plus $1.25 plus $1.25 plus $1.25, let's see what happens. That gives me $13. So that gives you $13 total. Okay. So that's Priya. Okay. And now we have one more left. So let's take a look at the last person, which was Han. So Han thought it should be $11.25. Okay. So how could we get $11.25 based on this prices? Well, I could do 12 and 1. Okay. So if I think of it as 12 bagels plus 1 bagel, okay, that's going to be $10 plus $1.25, which gives me $11.25. So we can see, based on all 4 totals, the shopkeeper, then Jada, then Priya, then Han, okay, we can see based on that, okay, that we can get all 4, it's possible to get all 4 totals, $16.25, $13.25, $13, and $11.25, okay? So that is your warm-up for today's lesson. What I want to do now is talk about the lesson notes. Okay, this lesson today is kind of an intro lesson to our overarching topic of Unit 4, which is functions. Now, you learned about functions in 8th grade, so some of this should be a review for you. But a equation or a graph or anything is a function if each input only has one output. So each input only has one output. So if the same input can produce multiple outputs, then that relationship is not a function. And I'll kind of explain to you what we mean as we go through the examples here. Okay. Now the input, you're going to hear me say input and output a lot. An input is whatever the x variable is. The output is the y variable. Okay. Now in the case of this unit, the x variable is also referred to as the independent variable, and the y variable is also described as the dependent variable. Okay, and the reason we call it the dependent variable is that it depends on how the x variable or the independent variable changes. And then we're also going to get into describing a function, okay? And the way we're going to do that is that the y variable is a function of the x variable, okay? In this case, I have an example. You might remember way back at the beginning of Unit 2, we did the water tank problem where we were filling the water tank, and then we also did a problem where we were draining a water tank. In the case of that problem, the time was the x, or the independent variable, and the amount of gallons in the tank was the y, or dependent variable, okay? The number of gallons either increased or decreased over time, depending on if it was being filled or if it was being drained. So the way we would describe that water tank problem is we would say, as it says here, we would say that gallons is a function of time, meaning that the amount of gallons changed over time, whether that be increasing or decreasing, okay, depending on if it was being drained or if it was being filled. All right. I'm going to talk more about this as we go through the examples. Okay. So on your handout, you're going to go to the back of that handout now, which looks like this. Okay. And we're going to go through these examples together. Okay. So if you need to, pause this video now and read through this problem here. All right, so we know what's going. So I would say pause this video and take a few seconds or minute and read through this problem. So we have a dog that is tied to a post. Okay, a dog owner tied his dog's 5-foot leash to a post outside a store while he ran into the store to get a drink. Each time the owner returned within minutes. Okay, so that means the most, okay, if we kind of look here, the most distance that the dog can ever be from the post is 5 feet, since the leash is 5 feet. Okay. Each day, the dog was 1.5 feet away from the post when the owner left. Okay. So that tells me, okay, so at time 0 on each of the 3 days, on time 0, when he left, that would tell me that he was 1.5 feet away at the point, at the time that the owner left. So when time is 0, the distance is 1.5 feet, which is why I put dots there. Okay. Each day, 60 seconds after the owner left, the dog was 4 feet from the post. So 60 seconds after the owner left, okay, the dog was 4 feet from the post. So each day at 60 seconds later, the dog is going to be 4 feet from the post. Okay, so I put a second dot there at 60 seconds. Okay. So for number 1, we're going to sketch a graph that could represent the dog's distance from the post in feet as a function of time in seconds since the owner left. Okay, so we know that these two things are happening on each day. All right, but other than that, it's going to be different each day, other than those two things. So we know the dog is 1.5 feet away at the time that the owner leaves, and we know that the dog is 4 feet away 60 seconds later. What happens in between and what happens after is going to be different for each day. So let's take a look at day 1. So day 1, the dog walked around the entire time while waiting for the owner. So the dog walked around the entire time while waiting for the owner. Okay. So that doesn't really give us a lot. So that means the dog at some point was just going back and forth. Okay, so maybe it went this way, then it went this way, and then we know at 60 seconds it was 4 feet from the post, and we know it can't be more than 5 feet from the post. So we know it can only go up there. So it's just kind of walking around, doing its thing until the owner gets back. So for day one, it could do, really, the graph could look like anything as long as it meets this point, and as long as it doesn't go more than 5 feet away from the post, since the leash is 5 feet. Okay? So that's just how I happen to draw it. If you drew it a different way, that's okay. Okay. 2. All right. Day 2, the dog walked around for the first minute and then laid down until its owner returned. All right. So we know it's 1.5 feet when the owner leaves. We know at a minute later, it's at 4 feet. And then we know after the minute mark, okay, the dog lays down. Okay. So for the first 60 seconds, it's walking around without a care in the world. It's doing its thing. It's going up and down. And then a minute later, it's 4 feet away from the post. And then at that point, it lays down. The dog lays down. Now, what does that mean if the dog is laying down? That means it's not moving. So that means a minute later, it's 4 feet away from the post, and then it stays 4 feet away from the post until the owner comes back. So the graph should remain flat at 4 feet after the 60-second or 1 minute mark. Okay, so it's walking around, it's doing its thing for a minute, and then a minute later, it's 4 feet from the post, and then it stops moving. It lays down. So that's what the graph is going to look like. All right. All right, let's take a look at day 3. The dog tries to follow its owner into the store, but was stopped by the leash. Then it started walking around the post in one direction. It kept walking until its leash was completely wrapped around the post. The dog stayed there until the owner returned. So it immediately tries to follow the dog into the owner into the store, which means it immediately goes as far as it can go, which is 5 feet. So it goes up to the 5 feet mark, okay? And then it walks backwards, okay? It walks back in one direction until we get to the 60-second mark, which we know it's at 4 feet, okay? So the graph is going to look something like that. All right, it tries to follow the owner of the store, but was stopped by the leash. So between 0 seconds and 60 seconds, it's somewhere in that interval, it's going to reach the 5 feet mark. Okay, but then it gets stopped by the leash, and then it starts walking back in the other direction until we get to the 60-second mark, which we know it was at 4 feet. It kept walking until its leash was completely wrapped or wound up around the post. Okay? If it's completely wrapped up around the post, that means by the time it gets to the end, okay, it's at the post. It's 0 feet from the post. So that means the graph is going to continue going down until it's wrapped around the post, meaning it's 0 feet from the post. So the graph is going to look something like that. It goes up to 5 feet, comes back down to 4 feet at the 60-second mark, and then it keeps going back down, all all right, as the leash is getting wound around the post. And then eventually, once it's completely wound up around the post, it's going to be stuck to the post. So it's going to be 0 feet. Okay. So it could look, your graph may look a little bit different, but as long as it's at 1.5 feet at 0, it's at 4 feet at 60 seconds, and somewhere in between that, it reaches 5 feet. And then at the end, it's back to 0. All right. So that's number 1. Okay. Number 2, for each function, which variable is independent? So if I can go back to the lesson notes for a second, the independent variable, according to our lesson notes, is the x variable. All right. So for each of these graphs that we drew here, if I look at the x-axis, remember that's the horizontal one, the x-axis was time in seconds. All right, so the x variable is the independent variable. So for each function, which variable is independent, okay, the variable is going to be time. Okay. For each function, which variable is dependent, okay? Well, in this case, the dependent variable, if we go back to our lesson notes, is the y variable, the one that's on the y-axis. Well, for each of these, the one that's on the y-axis is the distance from the post. Distance from the post, distance from the post. So that would be the dependent variable. Distance from the post. So that's number 3. Then number 4, fill in the blanks. Blank is a function of blank. So to fill in that, okay, we're going to look here where it says describing a function. The y variable is a function of the x variable, or, and this is a typo, the dependent variable is a function of the independent variable. So the y variable is a function of the x variable. The dependent variable is a function of the independent variable. So going back to this problem, we identified the y variable as the distance, and we identified the x variable, okay, as the time. So in this case, we're going to say y variable is a function of x variable. So my blanks is going to be distance is a function of time. Y variable is a function of x variable. Dependent variable is a function of independent variable. Okay, so whichever one is your y goes in the first blank, and whichever function is your x goes in the second blank. Okay, that is it for today's lesson. What I want to do is I want to quickly take a look at your cool down, which is in the slideshow as well. You can go ahead and type your answers directly in the slideshow. Okay, so let's take a look at the cool down here. Okay, in this case, the scenario is we're filling up a pool. Okay, so this pool problem is very similar to the water tank problem that we gave. So my hint here is to look at the lesson notes. Okay, so back at the lesson notes for a second. In the water tank problem, okay, you can think in this case, you can think of the water tank as the pool. Okay, time was the independent or the x variable, and number of gallons was the dependent or the y variable. Okay, whichever variable goes on the x-axis is independent, and whichever variable goes on the y-axis, okay, in the case of the water tank or the pool, that's the dependent variable. So you're going to want to use this. You're going to want to use this to help you complete the cool down. And again, you can type your answers right into this slideshow here and then turn it in. If you have any questions, feel free to email me. I'll be by my computer all day. Even though I'm not feeling well, I will be available and get back to you as soon as possible. All right. If you need to rewatch this video so you can fill in the handout and then save the handout so that you could use it on future CYUs and tests.